In level 4, it's just going to be more establishing identities, so not a lot harder than level 3 necessarily, but we're also going to be using our double angle identities in addition to the Pythagorean identities and all the others that we've learned. So in this first example, we are trying to get the left side equal to cosine of 2 theta. So we are looking to get one of these when we simplify, so we can end up replacing it with cosine 2 theta. So I start off by rewriting cotangent theta as cosine theta over sine theta. Tangent is sine theta over cosine theta. Same thing on the bottom. And we want common denominators so we can combine these. So I'm going to multiply this fraction by cosine theta over cosine theta, and this one by sine theta over sine theta, this one by cosine theta over cosine theta, and this one by sine theta over sine theta. And we will get cosine squared theta minus sine squared theta over sine theta cosine theta. I combine those into one fraction on the top right here. And then on the bottom, we multiply cotangent, or sorry, no, that's cosine. I can't read my own writing. Cosine theta times cosine theta, we get cosine squared theta. And then sine theta times sine theta is, oh, this one was a plus. Sine squared theta divided by sine theta cosine theta. Now, my sine theta cosine theta expressions will cancel. And on the bottom, cosine squared theta plus sine squared theta is equal to 1. That's one of our Pythagorean identities. So we end up with cosine squared theta minus sine squared theta. And looking up at our identities, that is equivalent to cosine of 2 theta. So we're done. Now in this next one, we are trying to get 1/2 secant theta cosecant theta equivalent to cosecant of 2 theta. Now, it doesn't matter which side you start with simplifying. Usually you want to start with the more complicated side and simplify it to look like the more simple side. So I'm going to start on this side. Now, if I'm trying to get cosecant of 2 theta, I probably want to first get 1 over sine of 2 theta, because that would be the same as cosecant of 2 theta. So I probably want 1 over this this double angle identity up here. So that's what I'm looking for, but let's simplify the right side of the equation and see what happens. So 1/2 secant theta is 1 over cosine theta. Cosecant theta is 1 over sine theta. I can rewrite this, if I multiply all these fractions, as 1 over 2 cosine theta sine theta. And if I look up at my identities, 2 sine theta cosine theta is sine of 2 theta. So we get 1 over sine of 2 theta, which would equal cosecant of 2 theta. And we're done.